Problem 3 here. We have a 14-point problem. It's a little more involved. We're given information about a dog walking east, north, and then at an angle. How far and what direction does the dog walk to get back to where his starting point? So we've worked lots of these problems. Always good to draw a good picture. The key here is all these vectors have to add up to 0. So let's start out. We're going to go east and then north and south of east. So east, north, south of east. So let's start about right here. Okay. Try to draw it about to scale. So there's 20. Let's get that fixed. 20 east. Okay. And 30 north. 25 south of east. Alright, at 35 degrees south of east. So we'll draw a reference east. We'll go 25 meters at 35 degrees south of east. So an angle right in there. I'm going to go 25 meters. Something like that. Okay. How far and in what direction does the dog have to get back to a starting point? Alright, so that would be this vector right here. Back to the starting point. Okay, good picture would get you probably 4 points or so on this problem. Just nothing more than that. Okay. Triangles would be very difficult. We have more than 4 vectors, more than 3 vectors, although you could possibly find this side of a triangle with the 20 and the 30 and then work it that way, but that to me is the hard part. So let's write out some vectors here. We have 20 and we'll use standard XY. Alright, and it's going to the right. Its X would be 20, and its Y would be 0. We have our 30 meter vector going straight up, 0 and 30. We have our 25 meter vector going down 35 degrees. Alright, so the X is going to be a positive 25. It's adjacent, so it's going to be cosine 35. The Y is going to be negative 25 sine 35. Okay. Our last vector, we don't know. Let's call it X. We don't know the angle. We'll call that theta. Let's call this vector R for return, just to avoid a little bit of a problem here. And let's just call the unknown component of that X and the unknown component of Y. When we're working with two-dimensional vectors, we can solve 2 independent equations, one in X and one in Y. Okay, and since they start and end at the same spot, both of those have to be 0. Alright, so I'm going to write it out here. 20 plus 25 cosine 35 plus X equals 0. And in the Y, I have, omitting the zeros, 30 minus 25. Oops, accidentally scrolled a little bit there. Fix that. Okay. 25 sine 35 plus Y equals 0. Don't have to show the algebra steps here. We can go straight to the solutions if we do this in our calculator, and we'll get X and Y. So let's come over here and do it in our calculator. Look up calculator. There we go. Alright, this one's pretty easy. I would not necessarily use the solver. I will just take these two terms right here, move them over the other side. They're both negative. So I will have a negative 20 minus 25 cosine 35. I can see from my problem that the x should come out to be negative, and it's 40.5 minus 40.5. Alright, I'm going to store that in x just to keep that, and I'll make a note of it here. Minus 40 point, let's call it 48. Okay, same thing for y, minus 30 plus 25 sine 25. Oops, 35. Careful with the numbers. Minus 9.52. Okay, so there's my two components. The question asks how far and what direction. Okay, let me double check my numbers here. 30 minus 25 sine 35. Alright, slight math error. I had sine here, typed in cosine, so second enter. We'll call back my previous calculation. Delete that and replace it with sine. Okay, slow down. 25 sine 35. 25 sine 35. Minus 15.66. Okay, how far and in what direction? I'm going to redraw my vector right here. So there's the vector I'm trying to find, r. And I go minus 15.66 in the y, minus 40.48 in the x. Okay, so this is the angle I'll work with here. Okay, so I've run out a little bit of room, but I'll just continue on down here. I can say the tangent of theta is equal to 40.48, again using absolute values, over 15.66. Theta is equal to inverse tangent. Oh, come on. Inverse tangent 40.48 divided by 15.66. Okay, 68.85. Okay, the magnitude of r is the square root of those two numbers. I'll just write x squared plus y squared. And let's see, second square root. Got x stored. I did not store y, so I'll type that in. 43.4. Okay, so my answer is going to walk 43.4 units of meters. Okay, and I could, with the angle I calculated there, I'll call it 69 degrees. Okay, and I am west of south. Okay, 69 degrees west to south would be the same thing as 90 minus 69, 21. You don't only have to give one answer. 21 degrees south of west. Okay, so either one of those references would work.